Hey guys, I hope you all had a great Easter break, and we have a short 3-day week this week, so should go by pretty quickly. We're going to start chapter 14 this week, which is going to be on quadratics. Okay, this is like the big chapter that I wanted to make sure we got in by the end of the year, and we made it. So there's quite a few lessons in this chapter. I think let me look here real fast. There's nine lessons. We'll see how far we make it. We should make it at least far enough that it should be good for the end of this year. But we're going to start off just looking at GCF and LCM. Now, we have done GCF and LCM for a few years now, just with constants or regular numbers. We're going to kind of take that further into terms. So we're going to look at GCF and LCM when you have variables and exponents and all of that. So just to remind you, GCF means the greatest common factor, meaning it's the largest number you can divide both numbers by. So if I said the GCF of 30 and 24, now most of you at this point could look at those numbers and realize that the GCF is 6. Oops. Okay, that's the biggest number that you can divide 30 and 24 by. I want to kind of take a step back and look at how we originally started doing this by, and then we learned a bunch of different shortcuts and we got really, really fast at it. But I want to look at originally what happens when you're finding the GCF, because that's going to help us whenever we're doing it with the variables. Just like with the numbers, there's all kinds of shortcuts to do with the variables too, but I want to learn what's actually happening first. So if we had 30 and 24, you could look at their prime factorizations. So 30 is going to be 2 times 3 times 5, right? 6 times 5 is 30. It's the prime factorization of 30. And then the prime factorization of 24 4 times 2 is 8 times 3 is 24. Okay, so those are both the prime factorizations. Now, when you're finding the GCF, you're trying to figure out what factors. Remember, GCF, the greatest common factors. You're trying to figure out which factors they have in common. They both have 1, 2, and 1, 3. Well, 2 times 3 is 6. Okay, so that's originally what is actually happening. And then we learned all kinds of shortcuts to be able to do it. We listed out their factors and did it that way. We did it with the dividing method. And eventually we got good enough that you could just look at it and figure it out from there. But just to remind you, if you go back to their prime factorization, you're going to use the factors that they have in common. Okay? All right. Now, on the other hand, when you're doing LCM, that's least common multiple. Okay, so that's going to be the smallest multiple that both numbers have in common. So if we were looking at the least common multiple for 25 and 15, okay, again, just to remind you, so if we did the prime factorization of 25 is 5 times 5, and the prime factorization of 15 is 3 times 5. Okay, now I'm not going to expect you all of a sudden to do prime factorization. I'm just using this to show you so that it makes sense when we do the variables. So if we were doing the least common multiple, that means they have to have the same multiples. So we look, well, they both have 1, 5 in common. So that means we need to add a 3 onto this number, and we need to add another 5 onto this number. So that's going to give us 3 times 5 times 5. Okay, if we took this 3 and we moved it over to here, and we took this 5 and moved it over here, now they're the same number, right? 3 times 5 times 5, 3 times 5 times 5. Okay, which is 75. So the least common multiple of 25 and 15 is 75. Okay, now the way you guys probably learned it was to list them out. So if you would have listed them out, and you list out 15, right, you would get the least common multiple 75. But again, this is what's actually happening. You look at their prime factorizations, and you have to add the numbers onto both to make them the same. Okay. All right, so when we look at this, we're going to do writing the GCF of these expressions. Okay, so when we first look at this expression over here, we have 6z to the third and 15z to the fifth. I'm going to go ahead and list out the prime factorization of 6z to the third, just to show you. It would be 2 times 3 times z times z times z, right? And then whenever I do 15z to the fifth, that's 3 times 5 times z times z times z times z times z. Okay, so when you're doing the GCF, that means if you look back at this first screen, when we're doing the GCF, we looked at what they had in common. They both had a 2 and they both had a 3, so we multiplied that to get 6. So when we look here, they both have 3 and they both have 1, 2, 3 z's. So the GCF here is going to be 3z to the third. Okay, here's the shortcut. When you're doing these, you're going to find the GCF of the coefficients, and you would say, oh, 6 and 15. The biggest number that goes into those is 3. And then you're just going to take your variables and you're going to pick the smaller number, because these are not in common with anything up here. Okay, so you have to pick the smaller variable, which is 3. All right, so let's try that with this next one. So we're going to look at the coefficients. We have 30, 24, and 6. So we want to think, well, what is the biggest number we can divide each of those by? All right, this is a pretty easy one. You should quickly be able to realize that 6 is their GCF. I'm just going to write this. Okay, and then you would take the smallest exponents. So our exponents are 4, 1, and 2. So the smallest one is to the first power. So your GCF is 6p. Now, if you did not know what the GCF of 30, 24, and 6 was, you have a couple options. Okay, and I'll go ahead and let you know what they are now. You could do the prime factorization of each like we did in the first slide. So 2 times 3 times 5 is 30. For 24, it was 2 times 2 times 2 times 3. And then 6 is 2 times 3. You could say they each have a 2 and a 3 to get 6. You could list out all of the factors. This one's a little bit more time consuming, so I'm not going to do it all the way. 30 is 1 times 30, 2 times 15, 3 times 10, 5 times 6. Okay, 24, 1 and 24, 2 and 12, right? You would keep going, and you would realize that the largest factor that they all have in common is 6. All right. Okay, so that's your other option. And then the last option was whenever we divided. If you remember that. We would say, what can we divide this all by? Maybe you noticed 2. And you'd say, what can we divide all those by? 3. Now we can't divide all those. We can't divide any of those. Right? If we could at least do 2 of them, you would do 2, but you can't do any of them. Multiply to get your GCF of 6. So there's 3 different options to help you if you forgot. And then for the variables again, when you're doing GCF, you're going to use the smaller exponent of the variables. I suggest that you pause the video and you write that statement down to keep it with you when you're doing the problems. I think it'll really, really help you. Okay, now let's look at LCM. When you're doing LCM, again, we need to find the least common multiple. So when you're finding the least common multiple, 4 and 10, I'm going to go ahead and write out the prime factorization of each. Okay, so 4x squared y squared is going to be 2 times 2 times x times times y. And then when you do prime factorization of 10xy to the fourth, that's 2 times 5 times x times y times times y times y. Now, if you remember, LCM, we are going to multiply more terms so that they're the same. So GCF, we're kind of taking terms away to make them the same. LCM, you're adding terms on to make them the same. Not terms, but factors. Okay, so we already have these are in common, these are in common, and these are in common. All right, so if you look here, we need to move a 2 down here, and we move an x down here. Those are added on. Now, on this number, we would need to move the 5 up, and then 2 of the y's up. Now, both terms, you're going to have 2, 2, 5, x, x, y, 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 y. 2, 2, 5, x, x, y, 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 y. All right, which is 20 x squared y to the 4th. All right, so when you're doing this, you're going to use the LCM of 4 and 10, which is 20. Right, so it's the smallest multiple they have in common. 4, 8, 12, 16, 20, 10, 20. And then for LCM, you're going to use the larger exponents. So we have 1 and 2, so we picked 2. We had 2 and 4, so we picked 4. So we got our 2 and our 4. Okay, so again, I wanted to do this part just to show you what's kind of going on behind the scenes, but you can certainly just use the shortcuts. And we're going to try that with the next one. So first thing we're going to do is find the LCM of 9 and 15. Again, we have a few different methods. We could do prime factorization and say they already have 3's in common, so we need to add a 5 and a 3. So they're both 3 times 3 times 5, okay, which is going to give you 45. Sorry, I thought I did it wrong. Which is going to give you 45. What was the second method I wanted to do? Oh, you could list out the multiples. So 9, 18, 27, 36, 45, 15, 30, 45. Okay, or you could do the dividing method. Divide those both by 3. Can't divide those both by anything. So we multiply the bottom row, right? You would keep going if you could, and you would multiply that L. But here we just have this bottom row. So 3 times 3 times 5 is 45. Right? I think that's all the methods. And then there's just, figuring it out in your head as well. So any way you do it, you get 45 as your LCM. And then we're going to pick the largest exponents of each, right? Because we always want to, add the, on to make them the same. So we would need to add 2 more x's onto here. I'm going to pick the larger one, which is 5. There is no y over here, so therefore the largest y has to be y to the 5th. We would have to multiply 5 y's onto this number to get it to be the same as the other number, or term. Okay? So again, the shortcut method for LCM is that you use the larger. Now I use the word larger to kind of help you, larger with L. Okay, so LCM, you're going to use the larger exponent for the variables. Again, I would recommend you pause this and you write that down to help you out whenever you're doing the problems. Okay. Please let me know if you have any questions. We're going to practice this today and tomorrow and then kind of move on. Still using GCF, we're just going to look at doing something a little bit different with the GCF on Thursday. Okay, good luck.